at what a lipid is, it contains a variety of different groups. And that includes things like fats, waxes, oils, and steroids. Fats we know about. We take a look at, a piece of fat on a steak. Oils, olive oil, waxes found in, candles and stuff, and found in the wax coverings of different types of plants. And then we have steroids. Now, steroids, a lot of people think of, oh, that's the stuff you make big, strong stuff. Well, steroids are also considered a lipid, and many steroids serve as chemical messengers. Okay, and we take a look at what's found in a lipid. Well, the elements found in a lipid are carbon, hydrogen, and oxygen. Well, if we go back, remember, carbohydrates also have carbon, hydrogen, and oxygen in them as well. Well, difference, of course, is that a carbohydrate has a ratio of 1 to 2 to 1. Lipids don't have this. Think about it. Well, if we take a look at, if you get a bunch of carbohydrates and you don't do anything, what happens? Well, that energy gets end up being turned into fat. So we have the same atoms, same elements as a carbohydrate when you're dealing with lipids. What are some of these functions that lipids do? Well, lipid is part of the biological membrane, part of the cell membrane. They're also used for waterproofing different types of coverings, such as in plants. Certain plants have a certain wax coating on the outside to help prevent water from transpiring out of those individual cells, for example. Now let's take a look at the form. So made up of two main parts. You got head and you got a tail. Those are the basic. Head is hydrophilic. Prefix hydro means water. Philic means to love. So water loving. In other words, it's attracted to water. The tails, on the other hand, are hydrophobic. Hydro meaning water. Phobic means to fear. So if you fear something, do you really like it? No, you dislike it. You hate it. So the tail part is the water hating part of, or the water fearing part of the lipid. This is the part that gives it its insolubility to water. In other words, it won't dissolve in water. Fats. If we take a look at fat, there are two main kinds of molecules in making up a fat. The first one is called glycerol. The second type of molecule is called a fatty acid. There is 3 fatty acids in making up one fat molecule. If we look at a fatty acid a little bit more closely, fatty acids contain a carboxyl group. If you remember back to physical science, that's COOH. Gives that acidic type property. If I combine different fatty acids in different combinations, I can make different kinds of fats. Here's an example of the different types of some of the different types of fatty acids. Different combinations of these fatty acids will create different types of fats. Here's an example of a fat molecule, a glycerol in particular. Saturated and unsaturated, polyunsaturated lipids. These are terms that you've heard before in health class or in the news or when reading a food label. Saturated means that just that. You can't add anything more to it. If I have a saturated sponge, can I add any more water to it? No. I have a saturated sponge, I add water to it, it just kind of spills off to the side because it's already full. So saturated simply means that the fatty acids contain the maximum number of hydrogen bonds. All right. If we take a look here at this structural formula here, we have carbons, a section of a fatty acid. You have carbon and hydrogen atoms combined together in covalent bonds. Each line represents a single covalent bond. A single covalent bond is the sharing of 2 electrons. Remember, atoms want to have the outermost energy level full. And what happens here is that carbon has 4 valence electrons. So it can combine with 4 different types of atoms, or 4 different atoms. So here we have 4 valence electrons, or 4 covalent bonds. 1, 2, 3, 4. So 2, 4, 6, 8. 8 electrons in the outer shell for carbon. So this atom is stable. We go with the next one here. 2, 4, 6, 8. 2, 4, 6, 8. 2, 4, 6, 8. So these are all stable. And of course, hydrogen, there's only 2 electrons being shared, and so 2 electrons around the outer shell of hydrogen, which doesn't meet the octet rule, but remember, hydrogen only has 1 energy level, and that first main energy level only holds 2 electrons. Let's talk about the next type of saturated fat, unsaturated. The prefix un means not. So it's a fat that is not saturated. Unsaturated fat is a fatty acid that contains at least 1 double bond. By doing so, this makes room for hydrogen so that it can be added. If it's unsaturated, you can add more stuff to it. So if we take a look here, this unsaturated, if it's stable here, we have 2, 4, 6, 8. So this carbon's stable. 2, 4, 6, 8. This carbon's good to go. Well, a double bond, and having a double bond allows for another carbon, the potential of another carbon to be added to, or a hydrogen to be added to this carbon right here, or something added to this one here. Now, in order to do that, though, we'd have to get rid of this double bond. So this double bond right here, we'd have to get rid of it, and then by doing so, that would give room for it to become a saturated molecule, like the diagram we just showed before. So here we have, like I said, an unsaturated, 2 bonds, allowing, if we got rid of one of these, so there was just a single here, we could add 1 more, meaning that there's potential for adding, so unsaturated. Now, polyunsaturated. Polyunsaturated means that there's more than 1 double bond. There's room for multiple hydrogen atoms to be added on. If we take a look at the diagram down here, this is an example of a polysaturated or polyunsaturated fatty acid. You'll notice here that there's 2 double bonds here. By having that, there's potentially room, if we got rid of this double bond here, you could fill in the gaps here. There's gaps here to be filled in by the hydrogen. This, the diagram above it, represents a unsaturated, and then of course on top here, this is a saturated molecule. You'll notice right here, this right here represents that COOH, that of course is the carboxyl group that is characteristic of all fatty acids. Fatty acids, when you have these double bonds, it's these double bonds that help create the bend in the fatty acid so that instead of being straight lines, they have a curve to it, which was shown a few slides previous. And that right there concludes today's introductory lesson to the wonderful world of lipids.